it's finally time to try and get the little Clio 172 Cup to 200 horsepower at engine dynamics. So what have we got? Clio 197 200 standard camshafts, which we got from Matt. We've got the Clio 197 200 injectors, because the standard ones are very nearly at max injector duty cycle to be deemed safe. We've got a new auxiliary belt. We've got a new dephaser pulley, because the old one isn't making any noises, but it's now gone. This will be its second Cambelt change, so it's certainly worth changing. We've got new Cambelt kit, obviously including the belts and all the idlers and the tensioner, and that is what we're going to need to get going. Now there's a few more bits I would recommend, one of them being the new seals for the camshafts. Unfortunately, where I usually buy them from are currently out of stock, so it's not great practice this, but because I'm doing it myself with the magical timing board, if it leaks, it's only going to be myself that's going to lose a few hours to redo it again and put a new belt and seals in. But I'm going to roll the dice on this one. We've got the Clio Sport Saturday coming up, and yeah, looking forward to getting these bits on and seeing how she drives. With the cams being a little bit more wild, we should see a bit more power up top, which is never a bad thing for a car that I love to rev. It's been 4.5 years since we've had the work completed on the Clio in the previous series, and as you can see, rust, paint flake from the wrinkle paint, plenum unfortunately started to oxidise a little bit as well. It's looking a little bit of a sorry state, but as I say, what we'll do now is get the upper engine mount undone just on the top half, jack the engine up from underneath. Ideally I'd like to undo the gearbox mount, but it's underneath all this heat shield, and the reason for that is when you jack it, it lets it slide that way to give us more room this side. With the Cambelt cover removed, you can now see the dephaser pulley, which is on the inlet camshaft, and then you've got a fixed pulley on the exhaust. Now when jacking the engine up, you can gain the access, which you can see there, but I do advise using either a wooden block or a rubber puck like I have, because you could crack the sump. Now the other thing when jacking up is just to be mindful of the brake reservoir. As you let the engine back down, I generally put a light hand on it to pull it forward, because if you catch that, pull it off, you're going to make a right mess of everything. But so far so good. It all looks pretty good in there. We'll obviously check shortly once we take the cover off, everything's still in time, which shouldn't have. It made good numbers, but we'll start stripping it down further, removing this plastic cover down here. And I say just take your time with this, because if you get stressed out you're going to break it, and they're not easy to come by to replace, as I believe they've been discontinued. And for those that saw earlier in the video, I oiled up the tensioner on the alternator. Now this is the 172 cup setup, so it's a non-aircon model that we're doing it on today. With the 3 bolts removed from the lower cover, you can now see it's ready to come out. Now unfortunately, because I haven't undone that gearbox mount because it's under my heat shield, it's not giving me enough room, and you're going to break it if you try and force it out there. So 2 options: either take all that apart. If you've got a standard car, you haven't got to worry about it, you can just undo the 213 slightly, and the gearbox will just let it rock backwards and give you that extra 10-20 mil to get that out. Or you can do what we're going to do today, which is just rest it in place, and when we start taking the cam belt off, we'll undo these 2, and then this will slide straight back up out of there later on. On my car it varies slightly because I've got the RS2 intake manifold, and essentially the standard inlet will bolt onto these points here and the front of the inlet where it curves back over. So it's pretty straightforward to understand, but it's slightly different on mine. Now the problem I have also got that I completely forgot about is I had a bolt shear off in this back one. So when we take this off today, we're going to have to drill and helicoil it potentially. But now with the engine resting on the subframe, you see the trolley jacks out, we can now start getting the locking pins in. Now essentially we've got the horseshoe bar, which is going to go in here. We've got a crank pin, don't know whether you're going to be able to see it, it's going to go in down there. I'll get the torch in a minute. It's an e-Torx bit, and then we're going to, as the engine's lowered now, we can put a socket on the end of the crankshaft and just rotate the engine until it lines up to get the tools in. With the main 16mm headed nut undone and 13mm just on the side there, you will now have the pivot point relaxed, and you can just undo the 10mm again at the front, and then now the alternator will be able to push it down, and you can see we've got a slack aux belt. This is the water pump here. You basically just need to slide the belt off the water pump, sorry, and then you can unfeed it from the lower compartment. The first one to remove is the bolt in the bottom of the block, which we tried to get an image of, which is down there, but essentially this is where you put the crank locking pin in. It's just a bolt that covers that up. It's an e-Torx bit. Unfortunately, I've lent my bits out and someone has not returned them, so we've had to use an 11mm multi-side socket, which does fit and has thankfully taken it off. In the garage, you can now see the genuine Renault locking tools. They'll also have the part numbers there if you do want to order them yourself. You've got the camshaft locking tool, these lock the camshaft pulleys, you've got the crank pin and the group N inlet timing tool, which we're going to be running today. So basically this and this are the same, but this sets the timing on the inlet slightly different for the power we want to achieve on the car. Gives that rally sound as well on idle. Really cool. I would always recommend using the genuine tools. I've never seen them timed accurately from the pattern ones, especially as a lot of people don't use the pulley locking tool. But the one we're going to need first, from what we've just undone, is the crank pin, and essentially there are balancing holes in the crank, so you need to be really careful where you position this, which I'll show you. So basically, if it goes in and there's still 10mm showing on that neck, you're not actually in. It should go straight but to the bottom there on that ledge there, and that means you're in the right hole at TDC. Sadly, I think it's going to be pretty difficult to see, but with my group end timing, the inlet is slightly arched like that and the exhaust is flat. Now if you go down to the gearbox side, you can actually see there's an 8° and a 0°, and there's actually a little yellow mark and a cut on the flywheel, and basically when that rolls to 0, you're in line. And I'm going to say it's pretty difficult to explain this on video, but essentially I'm going to push the pin in now, rest my weight on it, and then just rotate the crank until I hear the pin pop in, which hopefully we'll be able to try and get on camera. With the timing pin in now in the crank, you can see it's gone completely flush in there. We need to go and get the horseshoe that's going to go in there and check if the timing is still correct, and lock the cams in place to remove them. A quick look at the camshaft locking tools. This one on the left is the standard Renault item, and the one on the right is an aftermarket. Now if you look down at this height, you can see that these two are dead level, and on this one you've got a slight advance on the inlet cam. So as mine was timed with this previously, this will be the tool that we need to reinsert and reuse again for getting the best out of it. Like I say, a compromise for a little bit of low RPM idle power, up top gaining the screamer. So yeah, we'll go over to the car now, bang this in, and this should drop straight into the camshafts. Next up, we need to lock the camshaft pulleys using this tool from Renault. Now it comes with an additional pulley which comes in this box because originally it was designed for a non-VVT, and then Renault created this, which is for the VVT option, which we have in the F4R in the Mark II Clio Sport. And essentially there's two spaces in here. This will slide on, which you'll see shortly, and it holds the pulleys in place. If you don't use this, there's a good chance you'll either damage the camshafts or you won't time it correctly. I've seen plenty of other YouTube videos not using this, claiming they've done it. I'd love to see that timed up with a genuine horseshoe back in it, but I can't see it personally. There's years and years ago, it's been like 10 years since I was doing these on the daily. The amount of ones I had come in with people using patterned locking tools was just unfortunately a state, and it just costs you performance, mile per gallon, running issues. So it really is worth, if you're doing it yourself, either investing in these, or if you know a few people that are doing it, chipping in and sharing a set together. With the pulley locking tool in place, you can see I pushed it into the corner, then locked these up, and the same this way where the arrows go. You push them in, lock them up, and then use an 8mm to hold it. And the reason you have this is you're going to undo this cap, which is about 20 Nm from memory, and this is over 100. So if you don't use this cog locking tool, all the load goes through the camshafts into the horseshoe, whereas this allows you to lock it up with no movement in the pulley. Typical British summer. Rain. As the weather has unfortunately stopped play outside on the driveway, I thought we'd have a quick look at the dephaser pulley. So if you're not familiar, it is on the Renault Sport F4R 2-litre Clio Sport. It's even in the Mark III as well. It's a much more advanced version though in the later model. But basically, from memory, and don't quote me because it has been a long time, it allows 16 degrees of advance on the inlet camshaft, and you'll see there's little oil ways in there. And basically, there's a VVT solenoid, which I'll try and get a quick picture of, that loads the camshaft with oil, basically engages this and allows it to rotate. And when the locking pin fails, it sounds like a diesel when they rattle. It can also look like the timing's out when you go to put that horseshoe bar in the end. If it doesn't fit, but you can push it and twist it down, it means the pin's broken inside of it, and that's what makes the horrible noise. So this has now been on the car for 10 years. It hasn't failed. It still looks absolutely spotless in there, but for the aggravation of it, I've bought a brand new one to go on with the Cambelt kit. But we have got a little problem with the new bolts that we're going to be using and the seals, which we'll come to later, as Renault Parts Direct, where I normally get all my bits, haven't actually got anything in stock at the moment. So risk it for a chocolate biscuit. I'm going to use the old ones. If we get a big oil leak on track, it's going to be a bit of a disaster, but we'll know by the time we get to the dyno if we've got a problem. But yeah, going to have to reuse the seals because I've unfortunately left this well too late, and we're going for mapping on Saturday, which is 6 days time. And just like that, the Cambelt is removed, and you can see the crank pulley down the bottom. Thankfully, let's get my hand down there, my one is spinning, so it just slides straight off. He says for the camera. But what you may find is some of these actually seize on. You can see a little bit of rust build up there. They haven't got a Woodruff key on them. If you're familiar, basically in the Megans, these are keyed. There's a line there and a line in the crank, and these will lock into place. But on these, it's fully floating, which means these can spin, which that big bolt we just removed is the only thing holding it all together. But we'll clean that up now, and then we'll start removing all the rocker cover, because we're going to need to swap the cams out. So with the oil strainer removed, you can now see the exhaust camshaft. Now you're also going to need to do this procedure if you've got a leaky rocker cover, because unfortunately the rocker cover on this holds the cams in place. So it's not just an O-ring on the outside, it has got instant gasket. We are going to need to remove the VVT solenoid. This is what powers up the dephaser with oil pressure. So we're going to do those now in a pattern where it will be like a spiral essentially. You don't want to just undo one side and have the cover pop. So we'll just work our way around, and then the same for reinstalling it, which you'll see shortly. But we'll remove that now and the camshafts will be out. You can see that the horseshoe's no longer in there and the cams have sat in a sort of naturally rested position. For the love of God, do not turn the car on or start it now, you'd cause a right mess. But yeah, let's get this hot cover off, and we'll have a look at the rocker cover. With the rain continuing to come down, I've been forced into the garage, but perfect timing really, because I've got to do the rocker cover and the oil strainer. Now, this is the kit essentially that you would buy. You get the seal for the camshaft on the inlet cam, the exhaust cam, the dephaser bolt, the exhaust pulley nut, and the dephaser cap. Unfortunately, this is out of stock, so I'm gonna have to ghetto and reuse it. Now, thankfully, when these seals come out of here, when you split the cover from the head, they do just fall out, so you don't have to pry them out. So obviously, quick inspection, make sure there's no cuts or splits in it anywhere. These were replaced at the last changed. It's not ideal, and really, if you're paying a specialist, you'd want them done, because the labour to pull this all apart again if it leaks is going to be a nightmare. This one's just going to be on me if it does, because I've left it too late. But what I'll do now is I'll get a Stanley knife, just clean all this up, remove all the old silicone. It's gone a little bit heavy really, which is unusual for me. Normally I'm quite cautious with that. But yeah, we'll get these cleaned up, get them degreased, and then we'll do the cylinder head. With the engine side clean and the rocker cover this side all degreased, we can now look to seal it. Now, Renault do provide a Loctite, I can't remember the code, I'll try and put it in the description if you want to use the original stuff. I've always used this for years. The argument against this obviously is when you put it on, it can squidge out like you've seen, and unfortunately get drawn up into the oil pump and make a mess if you go too heavy-handed with it. The problem with the Renault stuff is it does seem to leak. Get it to 3 to 5 years old and you start getting all the weeping down the rocker cover onto the exhaust manifold, and then to replace it or repair it, you've got to take all this off again to be able to seal it. Honestly, I'd love it if it just had a proper gasket on there, sort of machined into it, and you could just fit it that way like most other vehicles. Unfortunately, that is not the option. So we're going to use this stuff today, put a light smear around the top here, put the cams in, and then we can put it all back together and torque down the cover. But unfortunately, the British weather again, you probably can just about see it on there, has started to rain once again. With the rocker cover now completely degreased, all the old silicone removed, it's ready to go back on. We've also JB welded the strainer, and essentially when that dries tomorrow and it's hard, I'll then put the drill bit through there, put a new hole in, put a new helicoil thread in, and essentially it'll have a steel thread, so it'll be nice and strong. But we'll go on that part tomorrow, which will make more sense. But yeah, essentially now we've got to go back out to the car and clean the lower half of the cylinder head, the part that we're now going to be bonding this back to eventually, so it needs to be just as clean as the top side. On the Clio Mark III 200 camshafts that we're installing today, they've got, I believe, a slightly higher lift and duration. They have got a pickup sensor on the inlet cam, which you don't require for this, but it can just stay in place. Thankfully, it doesn't get in the way. Now, what we do need to do on the inlet camshaft, which the dephaser pulley is going to bolt to, you do need to thoroughly degrease this so that when the mating face goes on with the dephaser pulley, it's nice and grease free, just on the end, or oil free even. But we'll clean all that now, degrease this end, and then we'll drop the cams in, get this cover filled with silicone, and then bang it back together. So it's been a while since I've done this. Like I say, it's a good couple of years now, and from memory it's 8 Newton meters on the 4 corner ones, just working around evenly till the cover sort of rests in position. And now we're going to work the spiral pattern, going 12 Newton meters to tighten off the rocker cover. As you hopefully saw there, I gave the pulley a quick sand with some wet and dry using some GT85 lubricant just to remove all the rust residue in there, and then quickly degreased it afterwards as well, because you don't want any oil on there. And then we need to just degrease the crank as well. All degreased on the bench, we've got the original exhaust pulley, the exhaust pulley nut, new dephaser pulley, old one being over there. The same bolt, as again, if you are doing this, I would advise replacing it if it is in stock, but unfortunately I haven't been able to do that. And the dephaser cap, again, something that if it goes wrong, it's going to leak everywhere and create a right mess. So all the seals thankfully look fine, so I'm happy to put it in there. Obviously we've got the new genuine Renault Cambelt kit, new tensioner, idlers and bolts, and those caps that we put a screwdriver through in the beginning. And as you can see, all the old ones are here that you can't reuse, unfortunately, so you do need to buy new caps when you do the Cambelt. Generally I always stick to the genuine Renault parts, but I say Gates do make the original kit. I think it even says on the belt if it still does. Yeah, so it's made by Gates anyway. So a Gates kit from experience has been fine in the past. Whether it still is I don't know, but they make it for Renault. Now with the tensioner, there's a small tab on the back which needs to line up with the gap there. It looks at it's about 6 o'clock, just underneath that stud. So when you slide it on, push it into the gap, make sure it's engaged, and then just finger tight this on for now. It doesn't need to be tight at all because we're going to need to back it off when we adjust the tension. Just quickly, before we put the crank pulley back in, you do need to check the main bolt. Now, these are reusable, but unfortunately, if they get stretched, they need to be replaced. And you're looking for under 50 millimeters from under the head to end of the thread. If it's any longer than that, you need to buy a new one. But if it hasn't stretched, you're cleared to go. Now, the only time I've ever seen these get stretched is when people just don't tighten them up properly, using impact guns, going past the point of the angle that's meant to be on them. So I'm hoping, we'll check this now and it'll all be okay. So with the belt now dressed in place, you can see the tensioner is fully backed off, it's not been done up. I've wound these in and then turned them back out half a turn, wound that in, turned it out back half a turn, and we've now got to put the crank pulley bolt in and the damper. So these are torqued up and the other idler down the bottom has been torqued up to 45 Newton meters. So once we put that crank pulley on, because the engine's locked at the camshafts and the crank, we're going to rotate this whole assembly, work all the slack out, put the tension in, work all the slack out again, and then we can tighten it all up. I'm going to do the crank pulley now, and I think that's probably going to be it for tonight. So it's the following evening, finishing off the Cambelt. I had enough last night, unfortunately. You know what, we'll finish this up today. So today's job, we've put all the pulleys on, all the idlers have all been tensioned up, the tensioner's still on the loose setting, crank pulleys in just finger tight, and what we're going to do is rotate the assembly backwards, which I'll show you now. So the cams are locked, the cranks are locked. We're just going to rotate and let the belt settle itself, put the tension in the belt, rotate it back again. Once the tension's done, we can then time it all up. With all the slack worked around the belt, we can now do the tensioner, which I believe, I'm going to double check it, but it was a 6mm, I think it's a 6 or a 5mm Allen key that goes in there. You basically rotate it up and round, and you can see you've got a little line there, and I'll see if I can get the torch to get in there when I'm done. But basically there's two marks that line up on the tensioner, one just at the top, one there, and when they're together the belt is tensioned correctly. And then again from memory, which I'll double check, I think this was 28 Newton meters. With the belt all tensioned up, you should be able to rotate it again backwards. It will be obviously a lot harder now because it's got the resistance of the tensioner in there, but providing those alignment points are all in point, you're then ready to go on and do up the crankshaft pulley at the bottom. As hopefully you can see down the bottom there, I've set up my angle gauge. We need to go for 115 degrees on top of the 20 Newton meters I've just applied. So there is a 15-degree tolerance on there, minus or positive, but we'll go for 115. It will be quite difficult to do. If you've got a fancy snap-on wrench, it will tell you in degrees without having to use the angle gauge. But I've gone old school and it's going to hopefully work for us today. With the pulley locker now in place and tightened up, these can't move when they're under load. And the importance of this is if you do these up now and you didn't have this on, you'd put all tension in the belt, which will pull the timing out again, hence the importance of this tool. So what we're going to do is 30 Newton meters on the exhaust, 90 degrees, and the dephaser pulley is 100 Newton meters. There's a little tip as well with propping the bonnet up a little bit higher so you can get a big breaker bar in there, which I'll show you now. With the pulley locking tool removed, that is it. The Cambelt change is complete. So what I would do now, and the reason we have the spark plugs out, is I'll do 6 rotations. And what you need to do is remove the crank pin, the camshaft horseshoe tool, and then using an 18mm socket, don't go backwards, go clockwise and rotate it through 6 revolutions, and then put the pin back in, put the horseshoe back in, and providing they go straight in without being forced, and the timing marker lines on the belt tensioner, you're done. With your 6 rotations complete, you should have had a free moving engine. It will go tight in spots as you rotate it, but essentially if it stops, you've done something incredibly wrong with the timing and potentially you've got valve contact. The good news is, because you're only spinning it over by hand, you're going to have done minimal damage, hopefully. So with the crank pin back in down there, fully inserted, we'll now take the timing bar, which probably won't be easy by one hand. Should have 2 really, but as you can see, no struggle. Both sides in, no real force required, which is what you want there. If you have to hammer it in or twist it or hang off of it, your timing's wrong, whereas it should just go in like that. A little wiggle's okay, but as you saw there, no force required after 6 rotations. With the crank pin removed and the horseshoe, you now need to fit the new blanking caps, as we put a screwdriver through the old one and put back in the original E-bolt in the bottom there, the E-Torx one. As I say, we'll do that now, and just be careful when you tap these in, because you don't want to go too far. Normally I like them just to the last ridge there and all squared up. I don't like them in wonky or at an angle. It's the little touches that finish the job off nicely. With the aux belt positioned in place, you can see it's tracked on all the pulleys correctly. This is really important because if the aux belt does come off, it can take out the cam belt. Using the 10mm nut, tighten it up until you're able to get a 45-degree twist in the lower section, which should be done with your thumb and forefinger. Ideally, you don't want it too tight to wear everything out and snap the belt prematurely or put extra load on the bearings, but at the same time, you don't want to hear it slipping or squealing. As 24 hours has passed, the JB Weld is now rock solid. So what I need to do is mark out where the spacer is for there, put the oversized drill bit in there, put a tap on it, put some lock thread in it, helicoil it, and then we should have a thread like this one again. So this is a little bit off the beaten track for what we should be doing for the video. But yeah, hopefully this repair will last. Otherwise, I'll just have to try and pick up a used strainer at some point. With the thread repaired, we can now move on to the next step and the final step, which is putting back on the strainer. Now essentially I've degreased all this. I'm just going to put the bead of silicone around it, we rest it on, and then we do all those bolts up to 12 Newton meters. Live on camera, no messing about. I'm confident with this. Well, let's hope so anyway. So the first job is to prime it, and the reason we do that is because we've had all the staying on one-handed, we've had all the fuel rail off, and you'll get like a hiccup and a misfire as it tries to go, as it's priming and starting at the same time. But honestly, I just do a couple of cycles. Listen for the pump. And then what we'll do is go back outside, make sure there's no leaking on the fuel rail, because we've plugged that back in and sometimes those O-rings do split. Here we go, first start. Now I'm expecting it to run pretty lumpy on idle with a slightly more aggressive cam. The dephaser pulley, brand new ones from memory, make a bit of a rattle on startup anyway. Let's check it's in neutral, yep. Obviously the gear stick makes a rattle anyway because it's a solid one. And we're probably gonna have a bit of smoke come out of there. Nothing to be alarmed about if it's just the oil burning off the manifold. But yeah, let's get into it. And like that, on the money, baby. Idles pretty well actually. Let's go and have a look outside, see how it all sounds.